Okay, so we have another problem here. So ethane is burned with excess air. So this is a complete combustion with a total pressure of 100 kilopascals. Determine the air-fuel ratio and the dew point temperature of the products. So we want to determine the air-fuel ratio. You need to find the number of moles of air, no? Okay. And to find the dew point temperature of the products, you have to determine the number of molecules per product, no? Of all the products, and then specifically we need the temperature of the water vapor. The molecule of the water vapor to find the temperature or the dew point temperature. So we have to do the chemical balancing again. So you have C2H6 as ethane. Okay, and then you have excess air, so 1.2 times the air, no? So A here is the theoretical number of molecules or the stoichiometric volume, no? So you have O2 and 3.76 and 2. And then this will be equal to X CO2 plus Y H2O, and then you have an excess, so you have EA. So just write here 0.2A. Okay, so EA and then O oxygen, and then plus Z and 2. Okay, so doing the chemical balancing, you can start with the carbon. So carbon here is equal to, so X is equal to 2, no? And then for H, you have 6 is equal to 2y, no? So therefore, this will be y is equal to 3. So you have x equal to y is equal to 3. For the oxygen, you have 1.2 A. So A times 2, no? And then equals to 2x plus you have y plus 0.2 A and then times 2. So you can transpose this to the left hand side, and as you can see, this will be actually you can divide this by 2 if you want, no? Just divide this by 2. So this will be just 1.2A and then minus 0.2A. So this will become just 1A, or A is equal to, so you have x plus y over 2 as your A. Is that right? Okay, it's transpose. Okay, cancel, 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 cancel. Okay, that's correct, no? So this will be equal to, so x here is 2, y here is 3. So you have A is equal to, so 2 plus 1.5. So this will be 3.5, no? 3.5. So for the nitrogen, the fastest way to do this is actually just multiply this 1.2A, which is 3.5, and then 3.76. So since both are N2, it will just cancel out, no? So the N2, the Z here is equal to, this is the calculator. So 1.2 times 3.5 times 3.76. So you have here 15.792. So 15.792. Ayan. Okay. So the next thing that we have to do, the usual thing that we can do, is to find their fuel ratio using molal basis, no? So MEA molal, this will be equal to, you have the number of moles is 1.2A, so this will be 3.5 times 1.2, no? So 1.2 times 3.5, so the number of molecules needed, no, of air, no, total, no, or the number of oxygen molecules needed, and then multiply this by 4.76 and then divide this by what do you call this, you have here 1, no? So since we have here 1 molecule of the fuel, so this will be equal to a, so this will be equal to 19.99, no? So this is kilomole of air over kilomole of fuel. Now to determine the the air fuel ratio through mass basis, we have to multiply by the molecular weights, no? So molecular weight of air and then molecular weight of the fuel. So the molecular weight of air is around 29. Molecular weight of fuel is we have 2 times 12 plus you have 6 times 1. So this will be equal to 30, no? So multiplying this to find the mass or the air fuel ratio, you have 19.99 multiplied by, so doing the analysis again of the units, you can multiply this by 30, sorry, should be 29 over 30. So because this is kilomole, kilogram of air versus the kilomole of air, no? And then you have kilogram of fuel over kilomole of fuel. So this will cancel out. So you have kilogram of air per kilogram of fuel. So this will be 19 point something, no? So times 29 over 32. Sorry, 30 only. 19.33. 33 kilogram of air over kilogram of fuel. Yeah. So we want to now determine the dew point temperature of the product. So you have to determine the partial pressure of the hydrogen. So to determine the partial pressure of, water vapor, this will be just the number of molecules of the water vapor versus the total, no, molecules of all the components, no, of the products. So you have here Y as the number of molecules. So this will be just 3. And then you have 2 plus 3 plus. So this will be 0.2 times 3.5. No? So you have 0.2 and then 3.5. And then lastly, your nitrogen. So you have 15. 0.792, no? So this will be multiplied by the total pressure, no, or the atmospheric pressure. So you have 100 kilopascals. So the pressure or the partial pressure of water vapor will be um, so it will be multiplied by 100. So this will be 13.96, no? Just checking, okay. 13.96 kPa. Yeah. So this is not the final answer. You can find the final answer using table 1 of your STEAM table, the first page, and you have to interpolate this in between. No, I just have note here, so this will be a quick one. So around 52 degrees and 53 degrees Celsius will be 13.96 kPa. Which is for 52 degrees you have 13.62, and for 53 degrees you have 14.309, no? So you have to find this temperature here, which is also the dew point temperature. After doing this, the dew point temperature will be equal to 52.49 degrees Celsius. So this will be your final answer. Okay, so that's it. Thank you guys.